Hello everyone, welcome back. This is Calculus 3. In this video, we are going to talk about 3.2, calculus of vector valued function. If you remember, we talked about the vector value function. So we have learned what our vector value function is and how to take its limit. So the next step is to learn how to differentiate and take the integral of a vector valued function. So the definition of the derivative, if you remember, of a vector, it's a pretty much, same thing you learn in Calculus 1. So it's the same definition we learned in Calculus 1. We're going to apply the definition of derivative into a vector value function, okay? So let's take a look at the definition of the derivative of, of the function. So this is a recall, right? So if you remember a long time ago in Calculus 1, that was all about, differentiation. So what does it mean, differentiation? If you have a function, so in Calculus 1, we deal with only one variable. So let's say you have a function. So by taking derivative of the function, you can find out the moment, you can find out the slope of the function, correct? So that was the definition of the derivative. So by knowing the slope, you can find out the tangent line that is touching that moment. So the line is going to be the linear, so mx plus b. That m we can find out by taking the derivative. And then the true definition of the derivative, you have two variable, and then they're getting close to narrow. The gap is going to be close to each other. You can find out the slope at that moment. So that was the we already learned in Calculus 1 definition of the derivative. So what happened is we're gonna use this again, identical definition of the derivative into the vector value function. Okay, so we have like xyz function, xyz axis. So you have like r vector, and then each point came from the component. So rt1, this is ft1, comma gt1, comma ht1. So you have a many function, the collection of the function, and these are all the points of the r vector. I want to find out the tangent line of that moment. They're infinite tangent line. You can think about it. So how to find out the slope at that moment? You can literally take the derivative of each function. So same thing. You can take the limit. You can take the differentiation. You can take the integral of the component of the vector value function, because it is the same role as a function input and output. So therefore, the calculation part is not really difficult. So let's take a look at example 1. So I want to find out the derivative of each vector function. So what happened? If you want to find out the r prime t, so you can find out, so this is the r vector. I want to find out the slope. I don't know where t is heading to, but I want to find out the slope that moment. So you can take the d over dt, rt. So that means you are going to take each component's differentiation. So d over dt for ln t. I'm going to move this one to the other side a little bit. Okay. And then we're going to take the d over dt, 8 radical t, d over dt, t second power. So we're going to work on this. So ln t, if you remember, ln t is going to be 1 over t. So 4 times 1 over t. And then 8 radical t means this is 8t to the half exponent. So when you take the derivative 8 times, you're going to bring 1 over 2, t 1 over 2 minus 1. And this is a 2t. So finally, 4 over t. And then if you solve this one, this is a 4 radical t o n 2t. So this is the differentiation of the r vector. So this is the general form. right? So you have all vector, and I found out the slope here. We don't know where t is heading to, but just leave it like that. So this is the vector from the x-axis, y-axis, and z-axis. So this is where 4 over t, 4 over radical t, and 2t. This is a general form of the differentiation of RT. Okay, so we could do the similar work in the next question one more time. So the next question here, I want to take the derivative. I want to find out the slope of the R vector. So that means you're going to take the derivative of each component. d over dt, t e to the negative t, d over dt sine 2t. A little bit of techniques of differentiation. So cosine t will be negative sine t. And if you remember, we are multiplying two functions. So this is going to be the product rule. So f prime g, g prime f. So f is a t, f prime is a 1. G is e to the negative t, g prime negative e to the negative t. So take a look at the derivative. So therefore, it is going to be f prime 1 times g plus g prime negative e to the negative t times f, which is a t. So e to the negative t minus t times e to the negative t. This is the second component differentiation. And this is the first. This is the second. Let's take a look at the third. You are going to take the differentiation of sine 2x. So if you remember, what happened? We have, oh, actually, there's a t second power. So let me rewrite it. We have a t second sine 2t. So same thing, product rule. So f is going to be t squared, f prime 2t. G is a sine 2t. G prime, if you remember, you're going to bring to the n. You're going to bring the n to the front, and then you're going to take a look at the derivative table. So 2 sine 2t will be cosine 2t. Am I right? So f prime g, g prime f, f prime 2t times g sine 2t plus g prime 2 cosine 2t and f, which is a t second power. So this is going to be your third component. So what happened? Our derivative, we got negative sine t, e to the negative t, t times e to the negative t, 2t. It's a little bit long, but sine 2t, 2 cosine 2t, and t second power. So that's the general form. This is a general form. This is a general form of the slope of the vector valued function in this problem, right? And then if t is whatever number even is given, you can simplify the answer as well. But we don't need to, they didn't give that information, okay? So that's the derivative of vector value function. So same thing, let me write it a little bit. So here, we learned so many information, but you can organize now. So vector valued function. If you have RT, you can take the limit by using the component, right? We learn in chapter 3.1. So I'm gonna make it a little bit smaller. Limit G, limit H. You can take derivative d over dt f function, d over dt g function, d over dt h function. And also, I'm going to show you later, you can also take the integral. What do you guys think? You're going to take the integral of each function. That's what we're going to do here today. Okay, so since this is the function, you can take the limit, you can take the derivative, you can take the integral. So I show you so far those are two. Okay, so let's go to quickly the next example, right? So now they want you to calculate the derivative. So what are you guys gonna do? Let's take a look at r prime t. Right, so what are you guys gonna, the component here is a 3t plus 4 comma t second minus 4t plus 3. So you're gonna do d over dt one more time. It's the same thing we just practiced. And d over dt, t second minus 4t3. So that would be 3. This is a 2t minus 4. This is the r prime. That's it. Okay, so this is the general form of the slope of this r vector. They want to find out something. Find out the slope when t equal to 2, then you're going to plug in here. So then 3 is constant and 4 minus 4 is 0. So this is the slope when t equal to 2. So you can evaluate, other slope, depending on the t as well. But this is a general form. Okay. All right, so now I'm going to show you a couple properties, right? The same property of the derivative. So if you remember in calculus 1, we learn all the properties of derivative, but here we are specifically using vector value functions. So it's a similar, but we have to take a look at a couple properties, which is a new. So the first one is a scalar. You can bring scalar to the front, then take the derivative. Plus minus, you can take the derivative separately, you can work derivative together. And the next one is important. So I'm going to show you scalar product, and then dot product and cross product. So we learned a couple different types of product. So the scalar product, it's the same as a product, the product rule. So if you're multiplying two function, so you're going to take the f prime g and then g prime f. This is same as a product rule. But what I'm talking about, the dot product, do you remember the dot product? So the dot product is different from the cross product and also different from the scalar. So the dot product, we have a dot, and then this is the thing. You're going to take the r prime times u plus r times u prime. But the cross product, if you remember, go back to chapter 2, please take a look at it. This is a different one, r prime times u, r times u prime. So let me write down the difference, because nobody gonna memorize it, but you're gonna take a look at those two examples a lot. And then the next one is a chain rule and everything is the same. Just I want to write it, the difference. While both involve multiplying the magnitude and of two vectors. I'm talking about the dot product first. The dot product, if you remember, results in a scalar quantity which indicate magnitude but not direction, right? So if you remember u vector, v vector, we have a u1, u2, you're multiplying that, u3, and then we have a v1, v2, v3. You remember u1 times v1, u2 times v2, u3, v3. So you will get simple number. So that indicate the scalar quantity, which indicate only magnitude, not direction. So that was a dot product. Same thing but different. Cross product, right, results in a vector which indicate both magnitude and direction. So we have, let's say, u vector cross v vector. So we used to have I, j, k, and you have a u1, u2, u3, v1, v2, v3. And by using the determinant, you get 3 different components because this is a vector. So therefore, you cross product, you will get the magnitude and direction because it is a vector. Dot product, you get just number. So that was a different, concept we learned in chapter 2. But we're gonna do the same thing. I'm gonna take a dot product and cross product in terms of here, vector value function. So this is the rule you're gonna follow. Dot product, yes, you're gonna take the derivative. We are taking the derivative of the r vector times u plus same thing product g times f times g prime, but this is going to be the dot product. So you will get the scalar plus a scalar, so you will get the one answer. However, the cross product, same thing. This is you're gonna take the f prime g and g times f times g, but here you're gonna get the vector outcome. So I will show you the work, okay? Just remember. We're gonna take a look at it. And I just wanna add one more rule, number 8. If you always multiply derivative, same thing twice, it is always 0. Just adding this information too. So these are property. And we talk about the dot and product. Let's take a look at the next question. We're gonna show you how to find out the dot and cross product in terms of the vector value function, okay? So let's do that work. So let me go to there slowly. So this is important slide. So exactly this is what I want to do with you. So the first one, our vector is given, isn't it? So we can rewrite as 60. I can calculate it simply, r prime. So r is this, and r prime, what do you guys think? 6i at plus 2j plus 5. Does it make sense? So this is 5k. So this is your component 60 plus 8, this second and third, and I took the derivative so I can find out r prime. Like I said, this is the component of u vector. So the u prime will be 2ti, 2j, am I correct? And then 3t second minus 3k. So we have a r prime and u prime. Let's do the dot product. And then it's a differentiation. Are you following? So according to the rule, it is going to be r prime t, right? Dot u, because it's a product, plus rt dot u prime t. So we're gonna take a look at it. So what happened? R prime, we just got 6i plus 8t plus 2j plus 5k dot what? U, which is a little bit long. T second minus 3 I 2t plus 4j. I need a space. I'm going to bring this one here. And then I'm going to bring this one here. And then plus t third minus 3t k. So this is the r prime u plus we have to do a couple more. R, we have r 6t plus 8i plus 4t squared. So we need long space. And then plus 2t minus 3j plus 5tk. Okay. That's u. And then what are you going to do? You're going to multiply with dot u prime. So we have a u prime right there. So I'm going to bring all the way down one more time. So u prime, which is 2ti plus 2j plus the 3t squared minus 3k. Wow. So you see that I'm going to highlight it. This is r prime. And then there's a dot. This is u. And then again, this is r, just r, not prime r. And then this is going to be u prime. And then what happened? We are using dot. This is a dot product. You're going to multiply them and adding, correct? So we're gonna calculate it. We know how to take a look at we know how to do the dot product. Go up, 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 up. This is a dot product. Am I correct? So you're gonna multiply each x quantity, y quantity multiplication and adding them up. So we're gonna do that work. So what happened? 6 times t squared minus 3, right? Plus the next one, 8t plus 2, 2t plus 4. And then 5 times t third minus 3t. Yes. And then this is the first dot product plus the second dot product, 6t plus 2 plus 8, 2t plus 2 times 4t squared, 2t minus 3 plus 5t, 3t second minus 3. That's it. And we're gonna expand it. That's what you're gonna do. You're gonna expand. So this is a dot product. So 6t second, 18, 16 second. You're gonna expand everything. 32, 48, 5 to t the 3, 15t plus 12t, 12t squared, 16t, all the distributive property, 4t minus 6, 15t to the third, 15t. So now you're gonna combining like term. You know what the like term means. I see the third, right, family, and I see what other? Second power, all the second power family. And then the last one, you will find out the t family. Yeah, you're just combining and all the number family. So if you're combining all the information, you should get 20t to the third plus 42t to the second plus 26t minus 16. This is the outcome of the dot product between two vector valued function. Does it make sense? So that's how you're doing it. It's not that complicated. Just remember how to do the dot product. I'm going to highlight them. How to take the dot product and cross product. Let's do the cross product next one. All right, cross product. So let me go up here. The cross product, we're going to do the same thing. The product rule, but in this time, multiplication is a cross. So let's take a look at it. So here, I'm going to use this color. What are you guys going to do? So we need to adapt. We need to adapt number 5 property. So dt, so you are going ut cross u prime t, correct? So it is going to be like f prime g, g prime f. So f prime is a u prime t. And then g, this is f and g. This is f and g. So if you think about it, f prime is a u prime. G prime is going to be u double prime. Am I correct? So think about it. F and G, F is a u and G is a u prime. F prime is a u prime. G prime is a u double prime. So by applying this rule, you will get, so u prime, that's an f prime. And then your cross G, which is a u prime, plus G prime is what? U double prime times F. F is what? U. So you're going to work on this. So this is the cross product. Are you following? So if you remember this one, this is number 8. Up. What did I say? It is going to be 0. So if you multiply same thing twice, it is always going to be 0. So all you need to do is the second part, correct? So we're going to do 0 plus u double prime. What is a u double prime? So we have to take a look at it. U double prime. So from here, you will get 2i plus 0, nothing there, and then 6tk. So that's your u prime, correct? We have a u prime, we have a u double prime. So u double prime, oopsie, right there. So u double prime, we got 2i plus 6tk times u, which is a t to the second minus 3. I plus, so this is 2t plus 4j plus, let me minimize it, plus t to the third minus 3tk. Are you following? So this is going to be u double prime. This is u. And we know this is a 0. So that's, and you need to take a look at it. And now what happened? This is cross. What does it mean cross? You're going to make a matrix and find out the determinant. So we are working on these two. So therefore, I, j, k. I'm going to write down the u prime first. T second minus 3. 2t plus 4. T to the third minus 3t. And then we found out the u prime, there's no j. So we have a 2, 0, 6t. So this is your cross product, correct? This is u t times u double prime. This is a cross product. So according to the determinants, right? So you're going to have the I, so we have 2t plus 4, t to the third minus 3t, 0, 6t, right? And minus j. So we have this and that. T second minus 3, t to the third minus 3t, 2, 6t. I'm going to minimize it. Plus k, t to the second minus 3, 2, 2t plus 4, 0. So we have I cross 60 times 2t plus 4 minus the 0, minus j, 60, t to the second minus 3, minus 2 times t to the third minus 3t. And keep going, the last one, plus k, 0 minus 0 minus 2 times 2t plus 4. So we're going to calculate that. This is a cross product. So you have 12t second plus 24t minus j, 6t to the third minus 18t minus 2t to the third plus 6t, k minus 4t minus 8. So if I rewrite it, This is going to be 12t squared plus 24ti. Combining like term minus 4t to the third. And then this is going to be negative 12t j. And then you can have, I can take out negative, so negative k, 4t minus 8. So that's your cross product. As you see that, the outcome is going to be vector 12t second plus 24 comma. You can have negative 4t to the third plus 12t comma. You have a negative 4t plus 8. This is the vector form because I multiply negative. So which is a differ, isn't it? For the dot product, you got the one solution. This is a scalar. This is a one number. But for the cross product, you got the vector form. So take a look at the definition cross and dot product. We're just using the vector value function. Okay, so definitely this is good to know. Okay, so we literally use the, this property, but this part, right? So I wrote the very important definition one more time, cross and dot product. Okay, so that's how we are taking the derivative and using and understanding its characteristic. So now, since we talked about the limit, the derivative, maybe we can find out the tangent line, isn't it? So let me take a look at the tangent line, next slide. So tangent line, if you can take the derivative, you can find out the slope of the tangent line. What is a tangent line? So when you have a function and you want to find out the line that is touching that moment, this is a tangent line. It is going to be y equal to mx plus b form because it's a linear. How to find out the m? You're going to take the derivative of the function. So what happened? We have a similar work. It's just, we are dealing with the vector value function, right? So what happened? Let's say you have a vector value function, r of t equal to cosine t plus sine t. You can take the derivative. So cosine is going to be negative sine. Sine is going to be cosine t. So this is going to be the vector slope of the tangent line. Okay, then if you have a specific number, you can plug in and evaluate it. So same thing we're doing over and over and again, calculus 1 to 3. Calculus 1, you learn the concept of the limit, differentiation, and the tangent line. We are changing the given function. Calculus 3, we are dealing with the vector value function. Are you still able to find out the tangent line? Yes. So we are going to have a, vector, the r, but by taking the derivative, you can find out the slope, and this is the slope of the tangent line. Okay, so just the same concept. I'm going to smoothly move on, and we're going to take a look at more example. But on one more thing, this is more important. The unit tangent vector. So we talk about the unit vector. If you remember, so you have a given vector, and then you're going to divide it by its magnitude. So that's how we are define the unit vector. So if I have a use, it's better using u, right? So what does it mean? You have a vector. There's a, the length 1, and then I want to find out that vector giving you the length is 1 out of the total vector. So think about the unit vector definition. Same thing, we can find out the unit tangent vector in terms of the vector value function. So the formula is similar. You're going to take the derivative of the given r and then divide it by its magnitude. We call that as a unit tangent vector. Okay, so let's take a look at the example. So by using that information, we can find out the unit tangent vector. So what are you guys going to do? You're going to take the derivative. So that is going to be 3t squared, 2, 1. And then we can find out the magnitude of that derivative of the r vector. It's going to be radical 9t to the second, 4 plus 1. So it is going to be 81. Actually, I already did the derivative. So you don't need to do this one. So this one, let me just change it 3. So it's going to be 9t to the 4 plus 5. So that's going to be the magnitude. So the unit vector is going to be 3 t second to 1 divided by 9t to the 4 plus 5. So you can simply you can separate them. 2 and 1. So this is the unit vector, unit tangent vector of this vector value function. Okay, so it's not like a complicated concept. So you have a unit, you have a tangent vector, right? You can find out the tangent vector r prime, and then you can find out the length just 1 out of the tangent vector. So take a look at divided by the magnitude. So that's going to be unit tangent vector. So same meaning, you can think about it. Okay. So I'm not going to do, number 5 and 6 because you're going to try. You can find out the unit tangent vector because we know the formula. So you're going to take this divided by the magnitude. So same thing here. So you can try both example 5 and 6. I want to do more complicated example. Are you ready? Ready? So let's take a look at the question, actually more difficult. So this is something I want to talk about it. So here, a little bit, different from, but here it's related to the unit tangent vector. Find the parametric equation for the tangent line to the curve defined R vector at the point 1, 3, 3. So, what is a parametric equation? And So if you remember, parametric equation x equal to, I believe, x0 plus at, y equal to y0 plus bt, z equal to z0 plus ct. So we have, the parametric equation form we learned in the previous units, but this is going to be related to the vector value function. So let's use all the given information. The point 1, 3, 3 corresponds to RT because they say this is at here. So what does it mean? You can say RT cosine t, 3e to the 2t, 3e to the negative 2t. It is equal to 1, 3, 3. And think about it. If t equal to 0, r0 cosine 0, 3e to the 0, 3e to the 0, exactly 1, 3, 3. So this is going to be happening when t equal to 0. So we just found out like t equal to 0, they're going to be corresponding to each other. Now, what I'm going to do, we need to find out the r prime to find out the tangent line. So take the derivative. So r prime. So r prime cosine will be negative sine t. And then it is going to be 6 e to the 2t, negative 6 e to the negative 2t. So this is r prime. So we know when t equal to 0, let's find out r prime 0. So negative sine 0, 6 e to the 0, negative 6 e to the 0, which is 0, 6, negative 6. So we have pretty much every information. So what are you guys going to do? We are looking for the parametric equation. Okay. So 0, 6, and negative 6. This is the vector we just got from the tangent line. So this is A, B, C of the tangent line, the vector on the tangent line. So let me make a little bit of space. So this is the vector of tangent line, correct? So therefore, 0, 6, negative 6 is a corresponding A, B, C. Am I correct? And then 1, 3, 3. This is the point. X0, Y0, Z0. So therefore, you have parametric equation, we got x equal to 1 plus a 0. 0 times t is 0. And then we have y equal to y0 is a 3. So I'm going to highlight it. This is x0, y0, z0 at. This is at here. And then this is your at ABC, the vector on the tangent line. So therefore, y is going to be 3 plus 6t, z equal to 3 minus 6t. So this is a parametric equation of the vector value function. So this is a little bit abstract problem, but think about it, okay? So I'm gonna do one more question like that, just one more example like this. So let me go down slowly, surely. All right, are you ready? Okay, so let's go to the bottom. So here we have R1, R2, we have two different vector value function. Ooh, they're intersect at origin 0, 0, 0. So one is going, another one is going. They're intersect 0, 0, 0. This is R1 vector, R2 vector. Each of them are vector value form. Find the angle that they're creating. Okay, so now we know the tangent vector, right? Because you can take the derivative and then you can find out the tangent vector. So the tangent vectors r prime 1t, it is going to be 3, 2t, and 3t second, correct? And then r prime 2t, we have a 2 vector. Sine is going to be cosine t. And then sine 5t, 5 times the cosine 5t, 4. So these are the tangent vector. Am I correct? So when you take the derivative, we have a vector. When you have a derivative, when you take the derivative of the whatever the vector, you can find out the tangent vector because, let me just get rid of this line. This is a tangent line. This is a tangent vector. You can find out by taking the derivative from the regular r vector. So that's what we got, tangent vectors, r prime 1, r prime 2. So same thing here. By taking the derivative, oopsie, you were able to find out the vector, tangent vector. So that's what happened. What happened? They're intersect. They are intersected at 0, 0, 0. There is t. I want to know when t equal to some number, this is going to be 0, 0. This is going to be 0, 0. So to find out that, think about it. If I'm just choosing random number, let's say if t equal to 0, r1 prime 0, 3, 2 times 0, 0, and 0. And then r prime, r2 prime, 0, this is going to be cosine 0. Cosine 0 is 1. And then 5 cosine 0 times 5 is 5 and 4. So what does it mean? Origin 0, 0 means t equal to 0. That's actually what they mean. T equal to 0 means you have a point at the origin. So therefore, I plugging in 0 into the tangent vector. So I got those two number. So what happened? That's what they're going to be. So this is going to be here. We have a tangent here, and we have a tangent here. They're going to be intersect as well. This is r prime. This is r2 prime. They're intersected at 0, 0. That's where t equal to 0. But my question is not finding this. I want to find out the angle that they're creating. So if you remember, to find out the angle, very important, to find the angle between two vectors. Do you remember a long time ago, two vectors? The formula, cosine theta equal to a vector times the second vector divided by each vector's magnitude. Yes? So we talked about this formula. The angle between two vector, you can find out the theta like that. So therefore, we have a two vector right there. So we're gonna use a tangent vector. So what are you guys gonna do? Cosine theta. We have a 3, 0, 0. This is a dot product. And then 1, 5, 4. And you're gonna divide it by its magnitude, 9, right? Or you can write everything if you need. 3 square, 0, 0. And then you have 1 square, 25 plus 16. So this is a dot product. I'm gonna highlight it. This is dot product. So we have one solution, right? So 3 times 3 plus 0 plus 0. And this is 9. And then the second one is a 42. So we have a cosine theta, 3 over radical 9, radical 42. We are looking for the theta. So theta will be cosine inverse that number. So you will find out the radian. This is a radian. If you multiply, so you can calculate this one in decimal. So that's a radian answer. If you want to convert it to the degree, just multiply 180 over pi. So you will find out the degree. So check it out. One is a radian answer, or if you multiply this one times this, you will get the degree answer. So that's how you do this question. So number 7 and 8, it's a more applicational problem. From the vector, we are extending our knowledge of the vector's characteristics. Okay, so that's something I want to briefly touch about. All right, are you guys okay with that? I think so far so good. Okay, so take a look at all the slides. Okay, the last concept we talked about the interval. We can take limit, we can take derivative. Okay, we can take the integral of the vector value function. So let's take a look at that last one. So integral of the vector, nothing is special. You can take the integral, you can separate it, and then you have a definite integral. You can find out the range, just keep going. You have a 3, you're gonna take the 3 components, you're gonna take the integral of the components, right? And then you can have a definite, you can have A to B, so you can take the integral. So integral is not that complicated. So let's do the example. I just want to do this last example. So this is the integral, so I can separate it, isn't it? So integral 1 to 3, 2t plus 4. And then we are going to take the derivative, and this is going to be in terms of I. Second, 1 to 3, 3t second minus 4. And then you're going to take the derivative with respect to t. This is a j. And then 1 to 3, 1 over. So this is the same as a t to the negative 2. I'm going to change it. T to the negative 2 dt. And then this is k. Are you following? That's it. Nothing is special. Let's take the integral. So this is going to be t squared divided by 2, 4t from 1 to 3. And then this is going to be, we know in terms of I. Second, we have a 3t to the third over 3 minus 4t. And then this is 1 to 3 in terms of j. And then last one, we have a t minus 2 plus 1 divided by that from 1 to 3. And then this is in terms of k. So we know what's going on. Now we are going to capital 3 minus 1. That's how you take the integral. So 2, they're cancel, 3 cancel. So we have 3 squared plus 3. This is a 12 minus 1, 1 squared plus 4. So this is the first in terms of I. Plus, we have a 3 to the third minus 12 minus 1 to the third minus 4. This is in terms of j. And then last one, so this is negative. T to the negative, correct? So if you take a look at this one, This is t negative 1 to the negative 1, which is negative 1 over t. So I'm going to use that number, plugging in 3 and 1. Negative 1 over 3 minus negative 1 over 1. This is in terms of k. Almost done. So you can simplify 21 minus 5 I. This is the 15 minus 3 j. And this is double negative. It's a 2 over 3k. So if you simplify 16i, 18j, 2 over 3k. So that's your integral. And then as a vector, same thing, 16, 18, 2 over 3. That's the vector after you take the integral. So I'm not doing everything. You can take the integral is much simpler. So you can take this one. You can find out the r. So what is that? R prime is given. So if you take the antiderivative, so to find out the r, you're going to take the integral RT. So you're going to take the integral, and then there's a r equal to 0. So you can solve for what the t as well. So try this example. And then if you need more problem, there's a more practice. So this is from the textbook. 3.2. You can also practice more in terms of the integral. So you can separate it, right? And then here you do the cross product first. Then take the integral. Try this. And the last one is also you can separate it. The distributive property, you can take the integral. That's all about it. So we learn how to take the limit, differentiation, and we know how to take the integral in terms of the vector valued function. So that's a 3.1 and 3.2. So you can master that concept. Don't forget the characteristic of the vector. We are keep using it, such as a dot product and cross product. Take a look at that. Okay. So feel free to, begin quiz 3.2. There are more embedded video. We have a discussion board. If you have any question, feel free to post and we're going to work together. Okay. So I will see you guys in the next video. Have a great day. See you soon. Bye-bye.